Question 2. Right, see here we've got something to do with altitude. We want to know whether it's increasing or decreasing. So we've got a rate of change. That means we're going to have to differentiate. Now we're only differentiating to the power. So the power of 2 we double. The h is h to the power of 1 and the number disappears. Let's tidying it up, and we want to put in the value of 8848 for the h, and we find that this is a negative value, so the pressure is decreasing at an altitude of 8848 meters. According to this model, when was the atmospheric pressure increasing and when was it decreasing? Well, we take that and we look at when it is 0 and we solve for h. Take the underlined bit to the other side and divide by the 2.38 times 10 to the negative 10, and you find that it will be decreasing all the way up to 44,538 meters. That's the turning point. So we can see that the mountain is less than that amount, so the atmospheric pressure is decreasing through the whole climb, which makes sense. Here we want a rate of change for the volume. Rate of change means we're going to differentiate, so you multiply by the power, reduce the power by 1. Tidy it up by cancelling out the 3's, v dash, and then we've got the radius is 2.3, so you just put 2.3 for the radius. Pretty easy question really. Here we want the rate of change, we're given the rate of change and we want the original function. So this is a negative x squared. It must have started off with a negative x cubed. So that's what we're looking at. First of all, look at the turning points. The turning points are at 1 and 3. And so we know that 3 is a turning point. We're told that at 2 we've got the maximum is negative 3. So as long as you've got your turning point somewhere at 1 and 3, could look like that, or maybe it could be a bit steeper like that, or it could look something like that. So that'll be my answer. It's only a sketch, so it's proximate, but you need the turning points at 1 and 3, and you need your h2 at 3. It wasn't a maximum, it was just a value. Right, for this one here, we're given the velocity. We want to find the distance. We know from velocity to distance, we anti-differentiate. So we write out the velocity equation, add 1 to the power, divide by the new power, add a constant. Now, it's from a fixed point, so the constant is 0. So we can eliminate the constant there. And we want to find the distance at 15 seconds, so just put 15 into the equation. Calculate that out, and you have your distance. We also want the acceleration at 15 seconds. So from acceleration to velocity to acceleration, differentiate. So differentiate the velocity equation, multiply by the power, reduce the power by 1, and put 15 in for t rather. And there's your answer. Well, if you get both of those, that's excellence. Here we've got a clothing store. We've got to calculate the selling price per sports top to maximize profit. Because we want the maximum, we're going to have to differentiate. But first of all, we want a profit equation. And this is probably the hardest bit. The profit is your income minus the cost. Now we are asked for the profit per shirt, so let's do the number of shirts times the price and take away the cost, and then divide it by how many shirts we've got. So there's the number of shirts times the cost, and we got the taking away the cost equation, divide it by the number of shirts, and then simplify inside the brackets by expanding it. Remember, all of that is divided by x. Tidy up what's inside the brackets. Again, it's all divided by x. And then divide x into each of those terms. And there's our profit per shirt. Because we want the maximum profit per shirt, differentiate it. So we're going to multiply by the power and reduce the power by 1, so a single number will disappear and the next term will become negative 1 times negative 4,000. Positive 4,000 x to the negative 2. We want to make it 0 because that's when it's a maximum profit, when the differentiated equation equals 0. Multiply by the x squared, divide by the 0.75, square root your answer, and it's 73. That's 73 shirts. We want the profit. There's a side of the price. There's the price equation. 150 minus 0.5 times 73. So you get the maximum profit when the shirt is $113.50. Now, just to show off your calculus and prove that it's a maximum, double differentiate, and then we know that that's a negative value, so therefore it's a maximum. And that's how you get excellence for that question.